the ozone level. It turns out that if it was just a little bit different, all life would be impossible. Now, let's just take this one as an example. If it's that sensitive, the ecologists like to say, gee, if the ozone layer increases or decreases by a fraction of 1%, cosmic doom occurs. Well, if it's that delicate, who balanced it in the first place? And who is maintaining its balance even today? The CO2 and water vapor level is the same kind of thing. So evidence in the microcosm. At the atomic and subatomic level, the slightest variation in any of these primary constants of physics, some as sensitive as 1 part in a billion, causes life to be impossible. And we have that many factors, each of which is that delicate, that all makes life a very, very rare thing indeed, and implies not only elegance of design, but elegance in maintenance, that to maintain those relationships. And so the more these relationships are, the more unequivocally they reveal both two things: skillful design in their origin and diligence in their maintenance. We've invented the most insulting god of all. We talk about pagan cultures that worshipped gods of wood and iron and bronze, whatever. We've invented the most insulting god of all: randomness, the total absence of information. We argue that all this elegance of design we see in the universe, in leaves, plants, animals, and ourselves, was all some kind of operation of randomness. That's utter nonsense. In fact, it defies the very definition of randomness. We need to understand some opposites. Disorder and order are opposites. Noise and signal are opposites. Engineers work hard to improve the signal-to-noise ratio of a receiver or a communication system. Music and cacophony are opposites, perhaps hard to discern today, but the chaos and cosmos are Greek terms for opposites, where cosmos is order and chaos is disorder. Randomness and design are opposites. The things on the left are examples of what's called entropy or randomness. Disorder, noise, cacophony, chaos, those are all forms of randomness or forms of maximum entropy. On the right here, we have the opposite of that: order, signals, music, cosmos, design, evidence of design. We need to understand those are opposites. It's amazing how many administrators today have no grasp that randomness and design are opposed to one another. In fact, we notice in the universe the flow, the natural flow, in the absence of intervention, the flow is always towards entropy, towards randomness. You notice that in your school locker at school, you notice that in the closet at home, the garage. You spend a half a day Saturday straightening it all out. It doesn't stay that way, does it? It goes towards randomness unless you assert the energy and the deliberate design to reorder things. It's interesting, the anthropic principle actually was used predictively. In 1954, Sir Fred Hoyle even predicted, and then did discover, the previously unknown energy levels in the carbon-12 atom. And this came about because he was sensitive to the patterns of numerical design in the universe. So he predicted that there would be a resonance involving helium-4, beryllium-8, and carbon-12. The mass energy of each nucleus is fixed and cannot change. The kinetic energy depends upon the internal star temperature, which can be calculated. He predicted there must be previously undetected energy levels. And he predicted it. Subsequent experiments confirmed him. And he's knighted over all this. He applied the anthropic principle to predict in advance, not by hindsight, the energy level at 7.6 million electron volts. Anyway, there's another discovery that amplifies the anthropic principle that I think is even more provocative. It's interesting, not only is our planet positioned for life uniquely, the right distance from the sun, the right size, the right speeds, all those things, it's also uniquely positioned for discovery. It's positioned in the galaxy in such a way as to be able to see the rest of the galaxy. It's positioned for total eclipses. Now, what's that got to do with anything? The idea of having a solar eclipse, that the moon is just the right size and the right distance to exactly obscure the sun except for the corona, is a very delicate mathematical relationship. Because it exists, it allows us to discover spectroscopy. And we're also positioned within the visible spectrum in such a way as to learn. If you change any of those things, often life doesn't exist, but also we would not be able to discover what's going on. What this all implies, strangely enough, isn't that it's just designed for life, it's designed for teleology. It's not even designed, that's clear. It also has been designed deliberately to be discovered. And The Privileged Planet, encourage you to check the book by Gonzalez and Richards, and there's some fabulous DVDs out on that that are just breathtaking in their scope. But the information sciences is where we're headed, and there are two concepts that are effective for us conceptually, but not in practice. One is randomness, entropy. The universe has most of us have been taught with what we call deterministic mathematics. 2 + 2 is 4, always. And that's most engineers are taught on deterministic mathematics. But there's another field of mathematics, stochastic variables, where you're dealing, say, with the average height of a man. What is that? Well, it has a range. It has a dispersion. It's a body of information that is variable but has certain characteristics. That's a stochastic. And it turns out in this world you often search for and need to have the use of a random number. Turns out you can't get one. You can get a pseudo-random number, something that's almost random, but the very act of getting the number implies some procedure, and that procedure is very likely to be subject to some kind of design. Getting a random number is a challenge to the technical community. The Rand Corporation, the granddaddy think tank of them all, in 1955, published a book, which at that time was a milestone. It was a book called 1 Million Random Digits with 100,000 normal deviates. And laymen looking at that would laugh. Here is a book. If you look at that book, I have one. I meant to bring it. 1 Million Random Digits. When I was there at Rand, I got one because I began to appreciate it as the years went by. It's simply a book of random numbers. Now, the naive observer would laugh at that, just random numbers. No, the numbers are as random as a computer can make them. What it means is that that each number that follows is not predictable. There's no symmetry. There's no periodicity. It has been washed by supercomputers every way they could conceive to make sure there's no patterns. It's truly random. Very difficult to achieve, and it was considered a milestone at the time. So its defining characteristic is that it's total absence of design. Design and randomness are opposite to each other. And to attribute our design of ourselves, our universe, to randomness is to not understand the very nature of what the word means. The Scripture says a little bit about this. The lot is cast into the lap, but the whole disposing thereof is of the Lord. In other words, the way Einstein said, God does not play dice. Do you know why? If he did, he'd win. God's in control. Now, there's a whole field of study because of the elusiveness of true randomness. It's called chaos theory. It's a new field of mathematics which tries to get at this fact that randomness is elusive. You can't find it. But there's a more interesting area that I want to explore, and that's infinity. We all use that word in school, but what is infinity really? Well, it has two dimensions. In terms of largeness, how big is the universe? And the great discovery of 20th century science is the universe is finite. It's not infinite. It may be expanding, but it's not infinite. And that's at the macrocosm. Let's take a look at that. Let's take this, the Vitruvian Man of Leonardo da Vinci as our symbol for man, and let's take size going from left to right, and let's look at the big things larger than man. This is a study of largeness. That would be the study of astronomy and astrophysics. The great discovery in that direction is that it's finite. It doesn't go on forever. The universe is big, but fixed, finite. Now, they also know the universe started. It began. That's what for lack of another term, they call a singularity, and that leads to conjectures of how did it start, and that leads to a collection of speculations called the Big Bang theories. And basically, they say first there was nothing, and then it exploded. If that's logical to you, embrace it. But we also know that ultimately, it's all going to burn out. The universe is it's been wound up, it's winding down. And there's ultimately a heat death. You see, heat flows always from hot bodies to cold bodies, right? We all experience that. If the universe was infinitely old, the temperature throughout the universe would be uniform. It's not. So it's not infinitely old. It had a beginning. That's what leads to the whole Big Bang concept. And so it had a beginning.